In this class, we will learn about 5 different types of number systems and we will see how they are related to each other. We start with the most basic number system, which is called natural numbers, or in other words, counting numbers represented by the alphabet N. And how do we count? We go 1, 2, 3, etc. and it goes on up to infinity. Now the smallest natural number is 1, and there is no such thing as a greatest natural number, because if you say 1 zillion is the greatest, then I will ask you, what about 1 zillion plus 12? So the greatest natural number is not defined. So we have one number system. Now why do we need more? The sun is still shining, the birds are still chirping. Why do we need one more? You see here, we are missing one number. What is that? The number which you see in the keyboard of your computer, what is that? 0, right? We are missing 0. So we need all of these numbers and we need 0. So this brings us to the second set of numbers known as whole numbers, denoted by the alphabet W. It has all the natural numbers and it has 0. So how does that look like? It looks like this. So the smallest whole number is 0, and there is no such thing as a greatest whole number because it is not defined. It goes on and on and on. Now we have two number systems. Why do we need a third one? What are we missing here? Suppose I am running a business and I make a profit of 100 rupees. Then how will I denote mathematically? How will I denote a loss of 100 rupees? Or suppose there is a building on ground above the sea level. Its height is 2 meters. Suppose there is a fish swimming below the water at a distance of 2 meters. Then how will I denote it mathematically? If extreme hot temperatures can be denoted mathematically, say as 40 degrees Celsius, then how will we mathematically represent extremely cold temperatures? For all of that, what do we need? This is how we represent loss. And you put a minus, this is how we represent the distance below the sea level. So for all of that, what do we need? We need negative numbers. That is what is missing here. So what we need here is all of the whole numbers and we need negative numbers. And together they are called integers, denoted by the alphabet Z. And how does it look on the number line? So as we go towards the right of the number line, the numbers increase. As we come towards the left, the numbers decrease. So 0 is neither positive nor negative. The smallest positive integer is 1. There is no such thing as a greatest positive integer because it goes on and on and on. But as we go towards the left, the numbers, their values, it decreases. So the greatest negative integer is -1. And as we go to this side, their value decreases and decreases. And there is no such thing as a smallest negative integer because it just tends to -infinity. It just goes on and on and on. So why do you think that -1 is greater than -100? That is what we are saying, right? We are saying that the greatest negative integer is -1. Why is that? Why is -1? Why do we think -1 is greater than -100? You just think of it in terms of, say, money. Suppose you have 100 rupees. If you lose -1, you will still have 99. But if you lose all of 100, what you have is 0. So a loss of -1 is always better than a loss of -100. So now tell me, what are we missing here? Why do we need another number system? Let me give you a clue. The problem is with this comma here. What is the problem with the comma? It means that after 0, we are jumping to 1. After 1, we are jumping to 2. After 1, the next integer that comes is 2. But that is not how it works, right? If you see in the number line, see 0 comes here, 1 comes here. What about the space in the between? What about all those beautiful numbers that lie there? We need a system which includes those numbers also. We need the integers and we need another system which represents all the space in this between. So, what will you find in that space in between? What are those numbers called? They are called fractions, right? What are fractions? It is not a whole of a number. It is just part of a number. It is the fraction of a number. For example, suppose I have a cake. I don't want to give you the whole of the cake. But I'm not that cheap that I'm going to give you 0. I'm going to give you something in between. So what do? I take the cake, cut it into 2 pieces and I give you 1, or in other words, I give you half. Or maybe I am cutting it into 3 pieces and I'm giving you 1. So these two are the examples of fractions. And fractions look like this. There is a numerator and a denominator. It is not the whole of a number. It is just the part of a number and it looks like this. One important point you have to remember is that q cannot be 0. The denominator cannot be 0. You cannot divide any number with 0. This is not going to happen because then it will tend towards infinity. But this is possible. 0 by 4 is possible because this is just 0. This is equal to 0, no problem with that. But the denominator cannot be 0. So we need a collection of such numbers which are called the collection of rational numbers denoted by the alphabet Q, and it consists of all the numbers which look like this. P by Q, where P and Q are integers and q is not equal to 0. Now, this is one way of explaining rational numbers. So we said, when we started, we said 5 number systems, right? So we just have 4. And how did we come to these 4 number systems? There was something missing here, there was something missing here, there was something missing here. We just kept on adding new things. So what is missing here? For you to understand that, there is another way of defining the rational numbers. Now, what is that one mathematical concept which is always related to the fractions? We mentioned that earlier also, the decimals, right? There are 3 types of decimal numbers. So, all the decimals can be classified into 3. First classification is terminating and non-terminating. What do you mean by terminate? Bus terminal, train terminal, you have heard of that, right? It stops there. So one kind of decimal, for example, half. This is terminating because this will be equal to 0.5. There, finished. It terminates. The other is it does not terminate. It goes on and on and on. And that can further be split into 2. Recurring and non-recurring. What do you mean by recurring? Recurring means to happen again and again and again. For example, 1 by 3. If you divide 1 by 3, you will see that this is equal to 0.3333333. It just does not end. It goes on and on and on. But you don't have to worry. Even if I ask you what is the 1000th, what number appears in the 1000th place, you will still be able to say that it is 3. Or for example, this 415, 415, 415, 415. It just keeps on recurring. It keeps on repeating itself. So the good thing is that even if I ask you what digit comes at the 1 millionth place, you will still be able to give me the answer. That it just goes on and on and on. So these 2 types, if it is terminating or if it is non-terminating and recurring, these can be expressed in the form P by Q, or in other words, these are rational numbers. It can be written as, in some form, it can be written as P by Q. 1 by 2 or 1 by 3, it can be written like this. So that leaves us the last one, which is non-terminating and which is non-recurring. How does that look like? It just looks like this, like any number. And what is the problem with it? You cannot guess what comes in, say, 50th digit, what comes as the 1 millionth digit. There is no way of finding out that. And so what can't you do? You cannot express it in the form P by Q. That is the problem there. If it is just terminating, you can express it in some form P by Q. If it is non-terminating but recurring, the same numbers coming again and again, then you can also, even that you can express it in the form P by Q. But if it does not terminate, it does not recur, there are new numbers coming at each place, then what happens? It cannot be expressed as a rational number, or in other words, it is an irrational number. An example of an irrational number is square root of 2, square root of 3, square root of 5, not square root of 4, because square root of 4 will be plus or minus 2, which is an integer. So that does not count. So an irrational number looks like this, and that is exactly what we are missing here. What we have is the set of rational numbers, and the set of rational numbers, there are two kinds. One, either it terminates, or if it does not terminate, no problem, it is recurring. So the rational numbers have only these kinds of decimal expansions. So we need another set, a bigger set, which includes all the rational numbers and also the irrational numbers, or in other words, irrational numbers are numbers whose decimal expansions will be neither terminating and it will not recur. So we need a bigger set which includes all the rationals and the irrationals. That is called the real number line, which includes all the rational numbers and the irrational numbers. The irrational numbers are usually denoted by the alphabet P. So it includes both the rationals and the irrationals. So we have 5 different number systems. And how are they related? We started with the set of natural numbers. It is completely contained. This symbol means contained. It is completely contained. It is a subset of the set of whole numbers. This is a set of, this is a subset of integers. That again is a subset of rational numbers. That again is a subset of the real numbers. So what do we have? Every natural number is all of this. It is a whole number, an integer, a rational number, a real number. Every whole number is all of this. Every integer is all of this. Every rational number is a real number. So the inclusivity works downwards, or like this. Every natural number is each of this. But then it does not work the other way. Every real number is not any of this. Can you give me one example which will satisfy that condition? For example, square root of 2. Square root of 2. Square root of 2 is this. It does not terminate. It does not recur. It just goes on and on and on. That means what? It cannot be expressed in the form P by Q. That means it is not a rational number. It is not an integer, not a whole number, not a natural number. Again, give me an example of a rational number which is not any of this. For example, 5 by 6. 5 by 6 is not any of this, because for integer, right from 1 you jump to 2. There are no fractions in between. So this example is not any of this. Now give me an example of an integer which is not any of these two. For example, minus 3. This only has positive numbers. And for the last one, give me an example of a whole number which is not a natural number. 0. So remember these examples. And now the inclusivity, it works this way. Every natural number is all of this. Every whole number is all of this. This way the inclusivity works, but it does not work the other way round. Now we come to the most important question. What is a number system? We have learned 5 number systems, right? So what is a number system and how is it different from a set of numbers? So a set of numbers is a random collection. They don't have follow any rhyme or reason. They don't have to follow any rule. It can even be empty, or it can be just any random collection. It does not have to follow any rules. But then the 5 number systems that we just now learnt, they are a group of numbers who have a purpose in their life. They all follow certain rules regarding, arithmetic operations. What are the 4 arithmetic operations that you have studied? Addition, subtraction, multiplication, division. They all follow certain rules. It is applicable. One rule which is applicable to one will be applicable to all of them. It is like a group of numbers who have a purpose in life. So they all follow certain rules. And what those rules are, inshallah, we will study it in the next class. They are like closure property, commutative property, associative property. We will learn that in detail in the next class, inshallah. So with that, we come to the end of this class. But before I go, we studied about 5 number systems, right? We started with natural numbers, which is contained in whole numbers, contained in integers, contained in the rational numbers, contained in the real numbers. So there is one more number system. I just stopped at this because this is all you can represent one dimensionally. What do you mean by one dimensional? Which means you can represent in just one number, in one number line. There is one more which is known as a set of complex numbers. I am not going to go into detail because for that you need a 2-dimensional figure. You need 2 lines like this. To represent complex numbers, you need 2 dimension. That is why I did not go into detail about that. But then, aren't you curious to know what are we missing? In each of these number systems, something was missing. So we took the whole of this and added new elements. We kept on adding new elements, right? And then we came to real numbers. And the real numbers, what did it have? It had all the set of rational numbers, or in other words, numbers which can be expressed like this, and the set of irrational numbers. That means the numbers cannot be expressed in this form. That was what we stopped at, right? What are we missing here? Let me give you a small clue. Example of irrational number is square root of 2 or square root of 3. So now tell me, what is that one thing? What are we missing that we need a bigger system which includes all of this and new elements? So look here, it is this. This is what we are missing. We don't have any number which denotes this square root of negative numbers. What is the problem with that? Square root of 4 is 2 and minus 2, right? But what about square root of minus 4? What is that number which when multiplied with itself gives minus 4? So you see the problem there? That is what the set of complex numbers will give you, inshallah, but that is for another day. Till I meet you next time, you take care. Assalamu alaikum.